This application software demonstrates the data mining concepts of clustering using the k-means algorithm on the Chicago crime dataset. We have implemented the algorithm in Java using the Eclipse development environment. And here we are showing you some of the source code, specifically the code for the graphical user interface that lets us run the clustering algorithm and show the cluster visualizations. Once we've loaded the project into Eclipse, running it is easy. We simply right-click inside one of the source files, go down to the Run As option, and click Java Application. This brings up the main screen. The two tabs here at the top will each lead you to a different screen. The one we're at right now is where we actually generate the clusters, and this one is where we calculate the validity of the clusters that were generated on the other screen. To generate clusters, we have to choose a file, choose an algorithm, and then we can specify the number of clusters we want and the distance measure to be used. In this other section, once we've created some initial clusters, we can validate them using any one of the 5 available validation indexes: C-index, DB-index, random index, Jacquard index, and Fowlkes-Mallows index. To actually run the clustering algorithm, we must select Edit on the top menu bar, click on the Load Dataset option, and then select the CSV file containing the pre-processed data. We have already pre-processed some data for the purpose of this demo, so we'll go ahead and select that data file. And up there at the top of the window, we can see the file name of the data that we just selected. Now, we just select the type of algorithm we want to use, enter in the number of clusters, and then the distance measure we want to use. Once we're ready, we just click on the Start Clustering button at the bottom. The output you see is just some raw output of the algorithm itself. At the bottom, you can see the number of clusters created and the total error, which is calculated using the sum of squared errors. Now we want to check the validity of the clusters we just calculated. We will select the index which we want to use and then click the Calculate button. And then the program will print out the DB index of the clusters at the bottom. This particular index yields a value of around 0.7. To visualize the clusters, we have to select Edit on the top menu bar and then select the Visualization of Data option. And this will give a visualization of the clusters in geographical space. You can clearly see the 10 clusters, and the number of crimes within each cluster is shown inside each cluster circle. In order to create this, we've used the Google Maps API in Java. We've decided to use k=10 for our clustering by using the elbow knee method as well as the various indexes such as the C index and DB indexes to make sure that was a good number of clusters. So here we see that the clusters of crime are primarily in the eastern side of Chicago. In order to interpret and analyze the clustering results in more detail, if you click on the map, you'll be brought to Tableau, where we have prepared some detailed statistics and visualizations using the CSV file that was the output of our k-means algorithm. Once it loads, we can click directly on a specific area of the main map to get details on it in the right-hand side of the page. We can also select each beat or district individually by clicking on it in the left-hand side list of areas. So we select the North Lawndale area, and we are shown the number of crimes committed in that area that fall under each of the 3 general categories we've defined: violent, property, and other. In addition, we can also see a small map of that area in the lower right-hand corner, which has a single dot for each crime incident that occurred in that area. We can zoom in on this map to see more detail and click on any dot to see the basic details of that particular crime. To filter the crimes shown in the report, we can use the tools at the top of the page in the top right-hand corner. Here we can choose any combination of 3 crime categories and then click Apply to recalculate the current results according to the new filter. The same thing can be done for the range of dates to display to the left of that. So that is all of our visualization for the clustering of crimes. Thank you for listening. Hello, this is a demonstration of the C 4.5 algorithm and interface that we developed for the data management project. Let's look at the source code first. So there are 2 main structures at play here. One is this C 4.5 node, which can hold other nodes of its type, right there in the children. It can possibly have a comparison value for when you're traversing the tree trying to get a classification. And for each record, you compare it using this node comparison. And it could be one of these, and you'll compare it to this comparison value, as we see down here. Depending on this type, we return this Boolean value or this Boolean value. And that's the decision that that node returns. Or rather, that determines if we should go to this node or not. It also keeps track of which attribute is being compared at this node. It keeps track of its parent so that we can traverse up the tree if we need to. And lastly, it has a reference to a seed tree, which itself also is a container of nodes, and it keeps track of just the root. It has a list of decision attributes, which is each column of the data set, which has a name, a type, which is either discrete or continuous, and a range, which is just a minimum and a maximum value that we use elsewhere. I have defined a bunch of utility types, some helper functions such as stuff like getting the mode or the split information or the entropy of a given array of values. And this is the whole class to run the algorithm. We do recursive calls to this split function, and then as for what I ran the algorithm on, we thought that using all 33 possible values for the class attribute was a bit much, and so we narrowed down the data set for this to be those crimes that fell into one of these 8 categories. Since we don't believe that C 4.5 can handle that many class attribute values as well. These are all the values that we could possibly split on in terms of the decision tree, but we found that not using all of them was actually better for this data set. And I'll show you, using those, all of them, we got an error rate of 47%. Now if we remove actually the year, the day, the beat, the latitude and longitude, so we'll run this now with just those attributes. And it actually takes less time since it's not having any continuous attributes, we can see we got an error of 42%. So that's around a 58%, 60% success rate. But we felt that wasn't still good enough to for the police to use it yet. So improving the error rate is some of our future work. Here is if someone did feel so inclined to use this, despite the high error rate. Here's how you would do it. You would enter it in a month, 1 through 12. Let's say dead of winter, 1 hour, 2 o'clock in the morning, location description. On the street, district 9, ward 20. And it's calculated, according to the decision tree, the most likely thing to go down at that point is narcotics crime. And that's how our thing works. Thank you for listening.